but just as a newcomer to the RISC-V and the chip design world in general. So, who am I? Well, I'm just a newly fresh graduate, but I have 1 year experience in FPGA engineering, and I have developed some prototypes of RISC-V and embedded system on FPGA. And for just 1 year of exposing to the RISC-V world, I do feel astonished by its progress and innovations. And I came here today to talk about a case study in how RISC-V help us to have everyone to access to chip design, not just industry specialists. And also, I will talk about some emerging trends in the RISC-V industry. So we start with a quote. As many have pointed out before, RISC-V isn't just another processor architecture. It's changing the game field of who can participate in chip design. So why do I say that? So let's start with a case study. Okay, so before I start, there are two parts that I present today. So the first part is the case study I mentioned, which is Adiaba Brain SoC, the award-winning chip design project, but built with the help of AI. And the second part, I will talk about some of the RISC-V emerging trends in the industry. So going to the first part, the Adiaba Brain SoC. So this is a project not as a really highly invested project by the industry, but just a fun project contributed by my college team in the Adiaba lab of the School of Electrical and Engineering Host. So this project won the first prize in a fabless chip design challenge. What makes this chip design challenge unique is that this a fabless AI-generated open source chip design challenge, the full name, is a chip design challenge that encourages the use of AI LLMs, in this case the ChatGPT 4.0, to speed up the chip design process. And in this challenge, we have to extend an open source RISC-V SoC, specifically the Carbo SoC, with the verified AI-generated components that can prove to be useful. Just an overview of the project. So this project is a neurosynaptic core that uses the spinal network NNN architecture. This spinal network is inspired by IBM True North SNN model, and the SNN model has the advantages compared to other architectures in its very power efficient, especially for specialized workload. In this case, it is used for a simple application of AI inference of handwritten recognitions. So this neurosynaptic core that we developed is then integrated in the Carbo SoC, and then it is used. We also developed the firmware for it to write the AI applications. But the most interesting part is that by utilizing the ChatGPT 4.0 power for the AI-generated RTL code, but still combined with our solid engineering fundamentals about digital design and chip design, we successfully speed up the whole RTL-to-GDSII design process to about nearly a month to compete with other players and won the first prize. Okay, so I am aware that this project is not actually really applicable just in the actual market. However, this is a very good case study of accessibility, I believe, because now chip design is just not for industry specialists and very invested companies, but everyone can be involved in the chip design project process, including students and hobbyists as well. Okay, so with that first case study, that leads me to the second part, is the RISC-V emerging trends in the industry. I will present three main parts. Firstly, is the RISC-V significance in the global stage, the real-world products, some of the real-world products chip that employs RISC-V architecture, and some of the key points of RISC-V future potential for anyone interested in the future to develop with to be a RISC-V developer or engineer. Okay, so to the first part, I will have a big quote to grab some attention. About the RISC-V market, this is a fun fact that I found on the internet. So the RISC-V SoC shipments, according to a market analysis by SSD Group, are expected to grow from 1.3 billion units in 2023 to 16.2 billion units by 2030. So we can see a very exponential expected growth for the RISC-V market. So according to this analysis, we definitely have potential to expand the developments of RISC-V SoC. In the global stage, this diagram is a little bit small to actually see on the for everyone, but I will take the key points here. Is the market momentum of RISC-V. This is a summary of all of the regions in the world that are adopting RISC-V architecture. So in this graph, the main players we can see is Americas with the blue with the purple colors, the China and Asia Pacific, and the red line is the total expected growth, and it is expected to grow by a lot, but till 2030. And I will mention some of the key regions in the world with RISC-V adoption. Firstly, China. China is definitely a leader in RISC-V adoptions. They have premier RISC-V international members, which is from Alibaba, Huawei, Tencent, and the China leadership in RISC-V adoption is a strategic response to US export control on traditional architectures such as ARM and x86. Also, another regions with heavily invested RISC-V adoption is European countries, with the main motivation to reduce dependence on proprietary architecture as well. So some of the key participants is the Nordic Semiconductor, Bosch or NSP, and a very big project that they are conducting is the digital autonomy with RISC-V in Europe, or the DARE project, which about 240 million euros in budget for the next generation European processors that focus on high performance and AI processor with RISC-V architecture. And also a very emerging market recently is India. So the Ministry of Electronics and Information Technology in India launched the Dear 5 Digital India RISC-V program in 2022, and Indian semiconductor market can be valued 38 billion in 2023 and targeting 10% global market share by 2030. So, of course, US is also still the leading innovator in chip design technology. However, US has been the places for very growing measure for very large company with already major architectures of chip, which is the ARM and x86. So the RISC-V is seen in the US as a consideration versus those major architectures. So it's competing with those architectures. So this is an overview map of the key regions in RISC-V with RISC-V adoption. We can, by the conclusion, it can be some observers believe that the China and India are key players for global RISC-V mass adoption. So why is that? We can think that since the US has already have very priority architecture such which is ARM and x86. So the other developing countries such as China and India needs the RISC-V to help them catch up and gain independence from the already developed countries in semiconductor industry. So there are also some good news of major companies adopting RISC-V internally. In just the recent event of 2025 RISC-V event, the NVIDIA has announced that its CUDA platform now also supports RISC-V, and it promised to continue supporting the RISC-V architecture in the next upcoming years. Also, the Western Digital, a really well-known company in the US as well, also released open source RISC-V core a few years ago for other developers to use. And Synopsys, a very prominent global EDA company, also actively participate in the RISC-V development. They release RISC-V core IPs for developers, as well as support many of the RISC-V development in their EDA tools. And they also participate in many of the RISC-V summit events in the world. So it's also very promising for their participation in the future. Also, I will introduce some of the RISC-V real-world chips that are actually on the market. So if everyone knows Sci-Fi, they have been the foundation members of the RISC-V community. So they have been developing RISC-V cores from the very first days, and they are still growing very well. And one of their recent cores is the Sci-Fi P870D core, and this core is have massive scalability. It can support up to 256 RISC-V cores, and it is used for data center configurations. And this one is also optimized for AI workloads in data centers. Also, like I have mentioned, China is definitely leading in RISC-V adoption. So there are many prominent RISC-V cores in the markets in China. So this one is very popular RISC-V cores is the Sofun SG2042, and this cause is popular because it's comparable. It can be comparable with other high-performance CPU cores from IRM and x86, and this chip can support up to 60. This chip supports 64 cores RISC-V, and those cores are high-performance cores with 64 megabyte system cache and can run up to 2 gigahertz clock performance. And also there's the Sontier C910 RISC-V chip developed by TH Semiconductor or Alibaba in China. It is a 12-stage superscalar pipeline out of order design and can support up to 2.5 gigahertz operation. And it is compatible with full Linux and Android OS. So, given the role of RISC-V in the global stage adoption and also some of the real-world RISC-V cores in the markets, I will take some of the points about the RISC-V future potential for the upcoming years. So there's the trend to shift from RISC-V low-end embedded cores to the high-performance computing and AI CPU cores. Since RISC-V is very flexible and it is very customizable as well, so there's strong push to develop high-performance RISC-V CPUs for data center and servers. Also, RISC-V is also very popular for developing accelerated AI workloads. There are many companies actively developing AI accelerators with the RISC-V architecture. The great thing about RISC-V is that it can scale to many cores to fit in a single chip. So it can handle parallel processing demands of machine learning models. And also, like I have mentioned, there are also major industry support for the development of RISC-V for high-performance computing. Like I've said, in the European countries, or the India, or China, or US, there are many companies and also governments support for the RISC-V development. Also, without the high-performance application, the RISC-V is also very well for domain-specific architectures. Its flexibility is ideal for creating specialized processors for emerging fields such as automotive, AI, and edge computing. And also this one is also have growing support from the industry. And in recent years, the RISC-V community has tried very hard to introduce more software compatibility with the RISC-V. And also, I think it's the most important, in my point of view, it's the most important advantage of the RISC-V architecture. It helps for the democratization of chip design. A big word, but simply just as other speakers has also mentioned, and I do think they are very important. Since RISC-V require no licensing fee or proprietary architectures, so it is totally open for everyone. So it also means that it can lower the barrier to entry to the RISC-V, which means it can encourage startups and smaller companies to design their own custom processors. And for our case in Vietnam, we can also utilize the RISC-V to actually catch up and to make our own designs that can be competitive with other players. So my last word is in my years in the RISC-V and in the RISC-V world and the RISC-V community, I believe that for any aspiring RISC-V developer to in the students here as well to go for it. So I believe the RISC-V has very potential future and career paths for anyone involved. Thank you.